Hello and welcome to another video. Today we're going to learn about fuels, which is an aspect of thermochemistry involving how it is that we get energy within our daily lives. Now, whether we're talking about within our bodies or if we're talking about the larger world like your cars or your homes to be powered, the energy has to come from someplace, and the typical place we get it from is things that we label as being fuels. So when we talk about fuels, we kind of need to know a little bit more about what the actual energy is that's coming out of them. So we assign a value to this, which we nicely call a fuel value, and it's basically the amount of energy that's released when 1 gram of a substance is combusted. Now hopefully you remember that combustion reactions are simply when you have something, typically a hydrocarbon as we've defined it before, but it can be anything reacting with oxygen. And as a result, it's an exothermic reaction. So you have a ton of energy being released most of the time in a lot of these reactions. Therefore, since it's exothermic, we get a change in enthalpy that is negative. So the delta H is going to be negative for these. So when we talk about fuels, there are two main sources of fuel we're going to discuss. One is food, which we use in terms of our internal energy, and the other is going to be fossil fuels. So for food, there are three main categories. You have carbohydrates, you have fats, and you have your proteins. So carbohydrates would be like glucose. So glucose during cellular respiration releases about 2,816 kilojoules per mole. If we look at it in terms of grams, we assign a fuel value to that of 17 kilojoules per gram of carbohydrate combusted. So a pretty decent amount of energy. Now fat is a much more energy-rich chemical, and it per mole releases on the order of 75,000 kilojoules of energy, so a considerably larger quantity. So when we look for a fuel value of that, it's 38 kilojoules per gram. So a lot more energy is stored within fat, which is why when your body has excess food or excess energy, its main storage area is going to be those fats, because you can put a lot of it per gram compared to carbohydrates. Protein, which is another main thing that we need to consume for amino acids and other things, also has a fuel value, which is 17 kilojoules per gram. So carbohydrates, fuel value is 17 kilojoules per gram. Fat, fuel value is 38 kilojoules per gram. And then protein is 17 kilojoules per gram. So if you want to look at like a bunch of different foods, like you can see here within this diagram that like apples, for example, have 13 carbohydrates, 0.5 grams of fat, and 0.4 grams of protein. So if you add all their kilojoules together, you end up with about 2.5 kilojoules per gram of apple. Versus if you look down, say, to cheese, cheese totals up, has a lot more fat content and protein, therefore it has a higher fuel value of 20 kilojoules per gram. So the more fat and protein found within something, typically the larger amount of energy you're going to be able to release. Now when it comes to fossil fuels, in case you don't remember these, are things that are basically dug up out of the ground from dead, decayed material, which makes total sense, right? I mean, let's dig stuff out of the ground and burn it to get our energy. Why not just use stuff from the sun? But that's getting into a whole other realm here. But basically we talk about like natural gas, coal, petroleum, which is just oil. And the way fossil fuels work is the higher percentage of carbon and hydrogen you have in the fuel, the higher the fuel value will be. So for example, natural gas has 70% carbon and 23% hydrogen. As a result, its fuel value is 49 kilojoules per gram. Pretty good amount of energy. Hydrogen, though, if you look at that, which is 0% carbon and mostly is all 100% hydrogen, since it's called hydrogen, I don't know why I said mostly, its fuel value is 142 kilojoules per gram. A lot more energy per gram comes from hydrogen than comes from natural gas or any other fossil fuel, which is why we really want to be able to figure out a way to use hydrogen as a fuel source. You get so much more energy for the same amount of mass, and as a result, you also don't send all these other pollutants into the environment. So hydrogen is kind of like that holy grail. We want to get to that point. So if we look here, these are just two tables, one showing you basically where most of the energy in the United States comes from. As you can see, a large part of our energy, most of it in fact, comes from fossil fuels, oil, coal, or natural gas. A little bit from renewable energy. Now these are outdated numbers slightly, we're a little bit better, this is from 2008, but still we are very, very dependent upon fossil fuels. The next table, table 5.5, just kind of gives you an idea of the fuel value based on the different types of energy sources. So if you look at wood, for example, like a pine tree, it's 18 kilojoules per gram. So not a ton of energy, but you still get in there. And then if you look down to natural gas, it's 49. So out of the fossil fuels, natural gas is one of the best in terms of fuel values, but it still can't compete with hydrogen, which is a lot more than that. So what we're going to do next is we're going to do an example, because I want to show you how to actually calculate this stuff using those fuel values. It's a really, really easy concept. Essentially, all you do is you take the mass of the different parts, the protein, the fat, or the carbohydrates, and you just multiply it by all the different fuel values, and then you add those together. So we're going to go ahead and do this as an example real quick. So make sure you have your sheet ready, and we're going to kind of go through it.
All right, so here we go with that example. So
as you can read along with me, it says 100 gram sample of fudge contains 2 grams of protein, 17 grams of fat, and 81 grams of carbohydrates due to all the supremely yummy sugar. The average fuel value of protein is 17 kilojoules per gram, fat is 38 kilojoules per gram, and carbohydrates is 17 kilojoules per gram. What is the fuel value of 100 grams of fudge in kilojoules and in calories? And then it gives you the conversions for calories and kilocalories and so forth. So we're going to go ahead and calculate through this to identify basically the amount of energy found within 100 grams of this fudge. So to do this, like I was saying, you just take each of the components, the protein, the fat, and the carbohydrates, and multiply by their fuel values and add them together. So if we start with this, according to our problem, we have 2 grams of protein, and each one of those has 17 kilojoules per gram. And we're going to add to that the 17 grams of fat found within the fudge, multiplied by its fuel value of 38 kilojoules per gram. And then add to that the 81 grams of sugar found, or carbohydrates, each with 17 kilojoules per gram as well. And we're going to add all those together. Now, as you can see, the grams all cancel out. So our final unit's only going to be in kilojoules. And if you plug this into your little voodoo box, also known as a calculator, you'll see that there is a total of 2,060 kilojoules of energy found within 100 grams of fudge. So the second question, part of the question, wants us to identify, well, how much is that in calories? So we have to do a quick little conversion. So we're going to take our 2,060 kilojoules and we're going to multiply that by a conversion to get us out of kilojoules and into kcal, because I don't have a direct conversion from kilojoules directly into calories. So the first step is to go out of kilojoules, which we know is 4.184 kilojoules for every 1 kcal, and then we're going to do the next conversion, which is 1 big C cal, or food calorie, has a total of 1 kcal in it. Kcals cancel, kilojoules cancel, calculate through, and you find that there are 492 calories, or food calories, found in 100 grams of fudge. So while fudge is delicious, probably not the best thing for you in terms of like food to eat on a daily basis. All right, so hopefully you have a really good idea of how these fuels work in terms of what a fuel value is, how to apply them and calculate with it. We'll do some more practice in class. We'll talk to you later. Bye.